this video we'll be solving quadratic sequences, so how to recognize them and how to find the nth term of a quadratic sequence. So something to keep in mind is all quadratic sequences are of the form an squared plus bn plus c, where a, b, and c are the numbers that we have to find. And this can be done in a few steps. So the first thing is, when we're given a quadratic sequence, so let's say we have the sequence 2, 3, 6, and 11. So what we're looking for is a difference, a constant difference in the differences between the terms. So first we find the differences between the terms. So the difference between 2 and 3 is 1, 3 and 6 is 3, 6 and 11 is 5. Now, because there's no constant difference, we know that it's not a regular arithmetic sequence. So let's see if we can find a pattern in the differences. So from plus 1 and plus 3, we know that there's a difference of plus 2. And from plus 3 and plus 5, we know that there's a difference of plus 2. Now, because there's a constant difference here, we know that it's going to be a quadratic sequence. And now, this number is really important for the first part of our quadratic sequence. What we have to do with this number, plus 2, we have to half it. So we know that 2 divided by 2 is just 1. Now, this is our a. This is our a value. So the first part of our sequence is going to be 1n squared. It's the first part of our sequence. Now, what we have to do is find the terms of the sequence 1n squared and compare that to our original sequence. So the first term, second term, third term, 3 terms should be enough. So let's find the first term of the sequence 1n squared. Well, the first term should be substituting 1 for n, so we would get 1. Our second term should be substituting 2 for n, so it should just be 4. And our third term will be 9. Now, let's compare that to our original. So our original sequence was 2, 3, and 6. These were the first 3 terms of our original sequence. So let's see if we can find a pattern between our sequence of 1n squared and our original. So to get from 1n squared to our original sequence, here we plus 1, here we minus 1, and here we minus 3. Do we notice a pattern in the differences? And so in all of the purple numbers, do we see a pattern? Well, we can see that from here to here to here, we're subtracting 2, minus 2. So, because we see that kind of pattern, we know that this is going to be our n value. So, this is going to be our b. So we take 1n squared that we found before, and we use this 2 as our b. So we now have 1n squared minus 2n. Now we've got this far. All we need to find is our c value. So we've now found that our a is 1 and our b is minus 2. All we need to do now is find our c value. So let's go ahead and do the same thing. Let's find the first 3 terms of the sequence 1n squared minus 2n. So 1, 2, 3. So the first term of the sequence would be 1 squared minus 2 times 1, which is just minus 1. The second term would be 2 squared minus 2 times 2, which is 0. And the third term would be 3 squared minus 2 times 3, which is 3. Okay, and again, we compare this to our original. So our original sequence was 2, 3, and 6. These were the first three terms of our original. Now let's see if we can spot a pattern in the sequence 1n squared minus 2n to our original. So here we have plus 3, here we have plus 3, and here we have plus 3. Now, because there's a constant difference, this is going to be our C value. So our final sequence is 1n squared minus 2n plus 3. So here our C value is just 3.